Welcome to Hidden Layers, where we explore the people and the technology behind artificial intelligence. I'm your host, Ron Green. We're back today with another Decoded episode where we take a look at the most important recent developments in artificial intelligence. The last few weeks have been kind of crazy, with major announcements from Meta, OpenAI, Google, and many more. To help me make sense of all of this, I'm joined by two of my terrific KUNGFU.AI colleagues, our VP of Engineering, Michael Wharton, and Senior Machine Learning Engineer, Nathan Mandi. Thanks for joining me, guys.
Glad to be here.
Thanks for having us, Ron.
All right, before we jump in, I wanted to answer a question we get quite a bit, which is, how do we stay up on AI? Which is really difficult these days with, how fast it's moving. So as you both know, we made the decision a few years ago to carve out every Friday, what we call it Lab Day internally, and it's focused exclusively on ongoing research and education. So at KUNGFU.AI, the entire engineering team, strategy team, et cetera, we take that time to read the latest AI white papers, to experiment with emerging technologies and packages and tools and APIs, and we do guest lectures and things like that. So it is challenging, even for professionals like us who work in this field every day. The pace is just off the charts, and I don't know what we would do without Lab Day.
Yeah, it's been terrific. We've had so many fun projects on Lab Day, and it's always great when something that we've worked on in the past comes to really help us in a future project.
That's a really good point. Is I think I've lost track of the number of times where something we figured out on Lab Day ended up actually being deployed on a client project in the future. So anyway, I just wanted to answer that question before we jump in. Okay, let me kick things off today with what I think is hands down one of the most exciting, if not the most exciting news that has happened so far this summer within AI, and that is the release of Llama 3.1 by Meta. So Llama 3.1 is the latest iteration in Meta's open AI models. And what's really important about this one is that they've changed the licensing model, or the licensing around the model, and it is now open weight, which means you can run all three versions of this model on your own hardware if you want to. So I've got a lot to cover here about this because I think this is really important for a bunch of reasons. So first off, the model's performance, as you both know, is just state of the art. It's absolutely ridiculous. It's up there on par with metrics from OpenAI's ChatGPT-4 and Claude 3.5 Sonnet from Anthropic. The fact that it is open weight is really important. That means you can run these models, like I said, but perhaps more importantly, they've changed the licensing so that you can use all three variants, including the really large 405 billion parameter model for downstream token generation. So you can use these models to generate outputs to train downstream models, which is really, really important because, Meta themselves even said in their really fantastic white paper on Llama 3.1 that they used Llama 2 extensively and several other models, which I'll get to in a second, to train Llama 3 and 3.1. So let's talk a little bit about the architecture. So I'm fascinated by this. It's really kind of a vanilla dense transformer. They didn't do anything special. There's no mixture of experts. They really focused on high quality data, and that was the difference here. The model really, I think, confirms that this move towards high quality tokens is the future, and it's not about just training on everything on the internet anymore. Keep it simple and amp up the high quality tokens, is how I'd put it. The model has 126 layers, 128 attention heads per layer. The embedding dimensions are 16,000 by 16,384. That's actually quite a bit smaller than I would have thought. About half the size of some of the other foundational models out there. Training, this is where it gets crazy. The These models are trained on 16,000 NVIDIA H100 GPUs. So that's about $500 million worth of hardware just right there on the GPUs.
Must be nice.
It must be nice, right? And then it was trained for a total of 54 days. And they go really exhaustively into the training regime and the failure modes. And, they had memory issues and GPU issues, and they were really transparent with all that. I think some of the training information is really important as well. So they used an initially small context window, 8K. This is really important. We do this all the time at KUNGFU.AI, right? Let's say we're training a computer vision model. We don't necessarily jump to the high resolution images right away. You start off with something a little bit smaller, let the model sort of get a good starting point before you increase it. And they said that they started at 8K, eventually moved up to 128K. That's, I think, if I remember correctly, that's 16 times the initial context window of Llama 1. This also helps because transformer models are quadratic in computational complexity. If you double the input, you don't double the amount of compute, you quadruple the amount of compute that you have to perform. And they said they only increased the context length once it was able to solve sort of, quote, needle in the haystack tasks in that smaller context window, which I take to mean things like asking it questions about the prompt that only appeared maybe once in the prompt early on. And so really challenging task out of the gate. The model was trained on 15.6 trillion tokens with a knowledge cutoff at the end of 23. So it doesn't know anything about this year. The mixture of data, again, very, very interesting. 50% of the tokens were general knowledge. 25 were mathematical and reasoning. 17% were code, so source code focused, and 8% were multilingual. And they said that they used a fast text-based model to classify the documents into 176 languages. So really great. And then a few more things, because I just think this is a really important development. According to one of the team members, they used a really sort of simple post-training process. They did rejection sampling, they used supervised fine-tuning, and they used direct preference optimization. So no reinforcement learning, just direct preference optimization. Relatively simple. This engineer said the approach not only performed best empirically, but it also was much more reproducible from a training perspective. So that's great. So here are my main takeaways. One, high quality data is increasingly the differentiator here. You really don't have to focus that much on complex model architectures. It's really increasingly clear that just plain vanilla transformers with high quality data can do really well. They used synthetic data. This now I think is the go-to. 2 years ago, you weren't really seeing this. You're now seeing everybody say this. Apple's paper that came out last week even mentioned it as well. I think that is a real secret sauce. And lastly, the scaling and emergent behaviors here are really interesting because in the paper, they say that they annealed the learning rate down to 0 on all three models. Was it 8 billion, 70 billion, 405 billion, yeah. Something like that, I think is for the small one. And it really had no effect on the large model because essentially at that point, it had acquired enough capability with its large parameterized set that its emergent behaviors and few shot capabilities were all that were really needed. You didn't need that sort of nuanced training. So again, simple architecture, simple training process, high quality data, giant parameter count, that's the go-to. So I think it's just amazing news. Mike, I'll throw it to you. What do you got that's happened recently that you're excited about?
Well, no surprise here, but it's meta related. Yeah, they obviously made a bunch of waves in the language domain with Llama 3.1, but with SAM2, their latest CV release, I think is also very, very impressive. It's already had a lot of offshoots that have been really interesting. And
SAM2 is segment anything.
That's right. Segment anything model. It's the second version of, I think we've talked about it on the show before.
I think we
just
have.
The regular SAM model. that one was impressive in and of itself. It was really, really good at segmenting objects with various types of input prompts. It could be points, it could be text prompts, masks, bounding boxes. They tried to make it a very generic workhorse that you could use for segmentation tasks. Well, with SAM2, they decided to add a dimension, add the time dimension, and go video. And that's particularly interesting for a lot of reasons. But I'll give you just a few details about what they did to make this thing in the first place. So they released it, I think, a week or two ago under an Apache 2.0 license. So just like Llama, it's totally open, free, do what you want. And side note, I was kind of thinking about the politics of that. Like, what does Zuckerberg stand to gain from this? Because he can't just be a total altruist here. Maybe he is, I don't know. But I think that from what I could tell, it sounds like they just really benefit from high quality, high volume content with their current business model. And if they can just provide tools to the public to just amp both of those things up as much as they possibly can, then they stand to benefit from WhatsApp, Facebook, all the social media stronghold they have, Instagram, you name it.
Okay, so hold on. I hadn't heard this before. That's really interesting. So your take is that helping people generate content with these generative models is sort of a part of their rationale for all of this open source that they're doing.
I tried to rack my brain about it, and that's all I could really come up with.
Okay.
Other than just pure altruism, which
and
they're still running a business, you know?
Yeah.
I mean, I guess where I typically go for open source motivation is like, they put Llama out there fully open source, and that really incentivized the ecosystem of developers out there to work with their tools more. And I figured that gives them more of a competitive advantage over some of the other LLM providers.
Yeah, it's a good point too, to kind of be a first mover in a way.
Yeah. Yeah, I don't have any inside information here, but I think it's that. And I think that it's also, we all work in AI. We really care about this progress not being locked up. And I think that that Meta, by being so surprisingly open here, is it enables them to draw some of the top talent. You want to be able to talk publicly about the work that you're doing, and I think that's a really important part of it. And I think it also sort of kneecaps, quite frankly, other companies like OpenAI, who their only differentiation is their AI models, and this is just a component of what Meta does. So I think it undercuts.
Oh, that's a really good.
Right, I think it undercuts some of that value there. So I totally agree. It's certainly not all altruistic, but whatever the rationale is, I love it. So
it's having a great effect on the AI ecosystem here.
Absolutely.
Yeah, I'm not certainly not complaining here. But yeah, so the SAM2 model. One of the cool things about it is they released this video data set. It's highly annotated. It's 51,000 videos, and there's over 600,000 spatiotemporal masks associated with that. So those are, they draw a mask around one frame, go to the next frame, and adjust that mask to be the same object, but in the next frame.
Right. Which,
interestingly, those objects might become occluded as part of these videos, and then it'll pick it right back up when it's on the other side. Some of these there's some very cool videos of like this kid jumping behind a tree and going on the other side of the tree, and the model just nails it. So it's really cool, high resolution. I think the average resolution was around 1,400 to 1,000 pixels or so.
Nice.
And in this data set, they're on average 12 to 13 what they call masklets. So uniquely segmented regions in one of these masks.
Wait, can I ask you a quick question on that? Do you know what is it about their training setup that enables them to track the occluded objects through the videos?
I'm so glad you asked. So it's a couple things to do with the architecture. I'll just start from the beginning here. So they have a pretty standard encoder. It's something called Hiera. I think that's how you pronounce it. I'm not sure. But it's basically a VIT, but it's their version that's more hierarchical and just faster, meant for real-time processing, because this is meant for real-time video processing. But what they do is they'll encode this into a vector, and then they'll condition that vector on both the prompt that you provide, like if that's positive points, negative points, text prompt, whatever you want. But it's also conditioned on memory. So I have this little memory bank that's attached to it that's a FIFO, first in, first out queue that has a certain number of frames, and it has the embeddings from those frames stored, and then it'll condition the encoded vector on those encoded memory snippets.
Fascinating.
And that's how they can keep track of, these included objects, because they still have, memory of what had happened previously.
Oh, fantastic.
That's
Which is kind of cool, right?
That's super cool.
That's a really clever idea. And I understand they can do 40 frames a second, right?
Oh yeah, it's super fast.
I mean, it's unbelievably fast. And I saw a video where you can pause the video. I think the video I saw was like a soccer player, and they were tracking the ball and both shoes. And then they said they unselected one of the shoes.
Mm-hmm.
And for the rest of the video, it only tracked like the left shoe of the player, which I just phenomenal.
Tons of occlusion,
constantly. Yeah.
Yep. Yeah. So it's incredible. And actually, I think to refine that process, they do have an actual head that predicts whether a particular region is occluded or not. And that's used for some additional processing. So it was clearly an important design requirement that they be able to handle occluded objects.
Okay. Is the source code available, or is it just the weights? Do you know?
I believe.
I think it's just the weights, right?
Okay. Yeah, just the weights. I'm going to trust you on this one.
No, don't quote me on that. Well, all right, we'll put it in the show notes. We'll confirm. But I think that's the case, but I could be wrong.
Yeah. Yeah, that sounds about right.
Okay.
But yeah, it's state of the art on all the visual object segmentation tasks that are out there. No real surprise there. The lead varies, but it pretty much just stomps the competition.
Wow.
And I'm just really excited. I've played around with it a little bit. I made some videos of just dummy stuff, and it reminds me of this old computer vision algorithm called grab cut, where you put positive points, negative points to try to just refine some semantic segmentation, some segment. And, once it does that, once you get that refinement on a single frame, it's just
off.
It's off. It's great. So highly recommend it. Check it out. It's awesome.
And that is on fire recently.
Yeah.
That is so cool. And I love that they were able to, leverage a memory store of embeddings really effectively there. Because I think that's the kind of thing that I'm expecting to start seeing more of. But this is the first, use case that I've seen on that scale for a foundation model that's this strong.
Right.
And this fast. Right.
Right.
Yeah. And this fast. Really, really impressive.
That's cool. I'm going to definitely take a look at how they leverage that, because it's something I'm very interested in. I think that that's a huge part of how we move forward from here with foundation models.
I totally agree. Yeah. Totally agree. All right, Nathan, what do you have for us?
All right. So taking us back to the text domain now, one of the things I'm really passionate about is the tooling that goes around the foundation model. Like the model itself is one thing, but really what it's about is the whole technology that we can build around it. So my update comes from Llama Index. And the headline here is they've released a series of small language models they're calling BRAG. That are fine-tuned specifically for RAG, retrieval augmented generation, and reach performance on par roughly with GPT-4 using KUNGFU.AI and Llama 3.1.
Interesting. Okay. And do they support different size versions of KUNGFU and Llama?
They do. Yeah. Yeah. So the best performing one, I think, is KUNGFU 8B. But they also fine-tuned a 1.5B, which they're calling their Ultra SLM. And part of the headline also is that it took them only $25 to train each of these 4 models.
Oh, that's right. I read about that. Yeah.
Yeah. So I think it's super cool. So just some background on Llama Index. So they are an LLM tool provider, similar to LangChain, and they're building out this whole suite of tools for question answering on documents, for retrieval augmented generation, and for agentic workflows. So getting your LLM to call arbitrary functions and API calls and things like that. And so workflows like this, you can potentially add a ton of value for getting something very specific that interacts with your data and potentially takes actions. But that whole chain you might end up with a dozen queries to your foundation model over the course of one data input. Mm-hmm. So if you're trying to scale this, your inference cost is a multiple higher than a chat system or something. Right. And some of these abstractions that they're building, like query engines, might involve sub-questions to, break down the question to smaller questions, get really specific responses, synthesize that. And so a lot of that is happening in serial as well. And so then your inference time is also, your latency is going up again by, and so they are very interested in leveraging small language models as much as possible. And so the fact that now with KUNGFU and Llama 3.1, they were able to fine-tune a model to be on par with GPT-4 roughly, I think that's a pretty big deal, and that will potentially unlock a lot of performance for RAG workflows, for agentic workflows.
Right.
And really like decrease your latency. It's not uncommon to see latency in the tens of seconds or a minute plus. And so imagine dividing that by, 5 or 10. That can make a big difference there.
Yeah, it can make the difference between being able to use something like that in production or not.
Right.
For sure.
Yeah, absolutely.
All right, that's fantastic. I love it. All right, I've got a little piece of news I want to cover. OpenAI. Lots going on over there. Okay, so I'm sure you both saw the news that John Schulman, one of the co-founders, announced, I think it was last week, that he was leaving the company. And he's not just leaving OpenAI, he's leaving the company to join their rival, Anthropic. John said, he's as passionate as ever about being focused on AI alignment. And he issued a public statement where he said he's not leaving OpenAI because their lack of focus on alignment, but sure, a whole lot of people from the alignment team have left recently. So I'm really not sure I take that at face value. And John was critical, not only was a co-founder, but he was involved in the development of reinforcement learning algorithms and was co-author of some really important papers, not the least of which is proximal policy optimization, PPO. So I think this is another really big loss for OpenAI. And then right on the heels of that, Greg Brockman, the president and co-founder, announced that he was taking a temporary leave of absence. So I think he said the rest of the year. So, 6 months to relax and recharge. So I'm not sure exactly what the heck is going on over at OpenAI, but there seems to be a lot of top talent, including co-founders, leaving. And moving to rivals. So a little concerning there if you're a OpenAI investor. Michael, I'm throwing it to you. What do you got that's interesting?
So I've got this little study that I thought, or this survey that I thought was kind of interesting that they talked about in a Forbes article. And the way the study was conducted is they just polled people all over the world. So it was a global study. And there were 2,500 people that were interviewed that mixed, it was a range of C-suite executives to freelancers to full-time employees. And one of the big takeaways from that, I'm sure if anyone has some sort of AI news feed, they've probably seen this takeaway headline clickbait, but it's that 77% of those employees say that AI has added work to their current workflow, and it's, causing negative effects to their day-to-day.
Did they give any examples in the article of what that type of extra work was?
I mean, my sense was that, these are just broad statistics, so who knows? But my sense is that a lot of people are conflating AI and Gen AI. I see that happening all the time. And, as we know, that there's a much broader world out there that predates ChatGPT. But I think another stat from that actually was that 81% of these executives say that they are expecting more productivity from the people that report to them because of these technologies. So I think there's just kind of this sour taste and people just expecting that, ChatGPT is going to make everyone's efficiency just go out the it's not happening.
I'd love to hear what you think about that, Nathan, but I was really puzzled by that. So my takeaway was it seemed like this might be a bunch of people who were like, hey, I have to go write this report and ChatGPT didn't get it right the first time and I had to go do some extra work and clean it up and that cost me time. It seems hard to believe that the use of AI is that widespread outside of just the generative capabilities, and they would be adding that much additional work because, on a personal basis, I use, as you both know, I'm using some type of generative AI. I want to say 50 times a day. It's making my life dramatically easier. And that's on the generative side, aside from the domain-specific neural AI capabilities. You have any thoughts about this, Nathan?
Yeah, I'm also kind of puzzled. I feel like at the very least, it should be not improving your workflow, right?
Right.
I'd be curious, I guess, to know a little bit more specifics if they provided any about what kind of delays it's causing compared to what they would have been doing otherwise, or if it's it's just clickbait.
Yeah, I mean,
might be. But
who knows what's behind it? There might be a little more detail that I missed in there, but in just preparing for this episode, I say probably a half hour using Claude.
Exactly.
Because there's something that doesn't jive there, but I know a lot of people are latching onto this headline and kind of taking it at face value. So
I think it's a little bit a part of that whole sort of backlash feeling.
Right.
AI is so hyped right now. I've said this before. We work in the field, and even I'm sometimes a little bit exhausted from the hype. So I think it's normal that there would be a little bit of backlash. All right, Nathan, you have any small news you want to share?
Yeah, sure. I have something uplifting, in fact. So there's this group called Climate.AI, which is a really just phenomenally international group of experts in both climate change and AI that have done a lot of work, like collecting use cases and case studies and informational material and like tutorials to help people who are interested in helping with climate change and in AI kind of cross from one field to the other. And they had a virtual summer school that was going on for the past few weeks here, and their in-person is actually going on as we speak. But I was connected with this group recently, and I just have been very impressed with their content. It's no easy task to distill down AI or climate change. Those are both hugely multifaceted fields. And so and they have a very large intersection, and they've done it phenomenally well. So some of the topics that they covered are AI for agriculture, forestry, land use. A lot of that is computer vision and segmentation to understand the land, what's there, and make decisions based on it. AI for conservation and biodiversity, just where there is data, how to leverage it well to understand, patterns in species migrations or population changes. Energy optimization and consumption, obviously a huge field of its own. It's like almost a whole nother subfield. And then also AI for helping measure, report, reduce. So understand the emissions of different entities. And measuring emissions is a very hard problem. And then also they had some content on climate finance, some content on like the ethics of AI, and of course the energy use of AI. So really a grab bag of so many different things. There was the intro Zoom call. I remember there were something like 300 people, and I think it was 100 countries represented. And I was like, I've never been in a room with 100 different countries represented ever. And it's like a very truly global interest. And so it's just really cool to see that.
That's fantastic. And what I love about that is that's an example, again, of sort of domain-specific AI, as a counterexample to generative AI. There are so many more ways that we're just at the very, very early stages of leveraging AI in these different domains to make the world a better place.
Yeah, absolutely.
All right, I've got something I really, really love. There was a new model release called FLUX.1. I'm not sure if either of you have seen this yet.
No.
Okay, so this is really cool. So this is from a new company called Black Forest Labs. These are the creators of Stable Diffusion.
Okay.
So this is a brand new state-of-the-art text-to-image generator, and it comes in 3 varieties: a pro version, which is commercial use, paid for; a dev version, which is, I've played around with it. It is almost as good as the pro version, and it is open weight, so you can run it locally. and then a smaller quantized version called Schnell, which is German for fast, and it's designed for sort of local development, personal projects, and it's with an Apache 2.0 license, which is another, great piece of information. The reason I'm bringing this up is the output from this model is phenomenal. It's on par with Midjourney. I've been playing around with it all week. If you want to play around with it, you can use, if you're on macOS, you can use Draw Things. I'm not sure if you played around with that yet. You can just pick the model, it'll download it. There's a little tweaking you have to make, but it just runs out of the box perfectly. And I'm on an M1, so, a 4-year-old CPU, and it runs terrifically. You can get Midjourney level realistic images out of this. And interestingly, it does a really great job on fingers and hands, which, strangely it's been
difficulty.
Yeah, it's been a really hard challenge within this space for years, and it is phenomenally good at it. And so the dev model is a 12 billion parameter model. It uses a rectified flow transformer. It can generate images, and I've seen people take these images as input into like Gen 3 from Runway, and it produces just breathtaking videos. So I think this is a really, really great move. And one more point about that is they used T5, Google's, quite a bit old by this. This is like old news at this point, the text-to-text transformer, and they use it to describe the images and to get really sort of really high quality interpretations of the prompts. Really, really great news. So check that out. We'll put links in the show notes on how to use this with KUNGFU.AI and Draw Things and other approaches. Michael, I'm going to throw it to you.
All right, let's talk about regulation.
Oh boy.
Here we go. No, I think it's really interesting. We've also talked about the regulatory environment on this show before, but I think it's really interesting now that the EU AI Act is totally in play, it's enacted, and it's active. And for those that aren't familiar, this EU AI Act basically it regulates different risk levels of technology in different ways. So they classify it in these 4 different categories, and they are unacceptable risk, high risk, limited, and minimal. So unacceptable would be things that are like exploitation or manipulation or like social scoring, stuff that's just really intuitively bad. And, what's the purpose other than control? Mm-hmm. The high risk stuff is where there's some actual potential harm, but might be a lot of benefit too, like medical devices or, things kind of in that nature, loan decisioning, stuff like that. Limited risk is stuff like chatbots. So that has its own set of transparency requirements, testing, et cetera. And then minimal, which would be things like a spam filter that, pretty low risk.
Okay, I was kind of wondering what would fall under minimal.
Yeah, that makes
spam
sense. Filter.
Okay, there you go.
But I think it's interesting because the EU has been on a tear in terms of regulation. I mean, GDPR came out not a while ago, but not too terribly long ago. Right. And we saw how that affected companies in the US. I mean, GDPR compliance was like this big... You hear that phrase everywhere you turn for a while. Yep. And it's still a big deal, but it really did impact the way business was done here in the US. And I think in the similar way, the EU AI Act is not going to be that much different. I think it's too early to tell exactly how it's going to affect things. But, there's all sorts of other regulation like the DMA, the Digital Markets Act. Mm-hmm. And Apple, because of this whole regulatory environment, they're not releasing their Apple Intelligence product in Europe, at least for the time being.
That's right, yeah.
And Llama 3.1, there's apparently a multimodal version that Zuckerberg came out and said, we're not releasing this in Europe either.
I saw that as well. Yeah, just because of the uncertainty around the regulation and whether it is or is not going to violate some of those new governance rules.
Yeah. So it clearly does impact our day-to-day, at least the tools that we typically talk about and use.
Yeah.
And I think it probably is going to be a good thing because if it requires a lot of transparency in Europe, I mean, geographic borders are pretty wishy-washy on the internet. So we're going to benefit from all this transparency and testing and stuff that's required in Europe. So
right. That's great. All right, I'm throwing to you, Nathan. What do you got?
All right. So let's talk about an update from DeepMind. They released AlphaProof, and their big headline was that between that and alpha geometry, their models are now capable of placing at the level of a silver medal in the IMO, the International Math Olympiad. And so this is pretty interesting, especially in the discussion around intelligence. So some context: the IMO is, I got a quote from their release. It's the oldest, largest, and most prestigious competition for young mathematicians, held annually since 1959. And that really sums it up well. This is a big deal. And, why are they going after the IMO? Well, advanced mathematics is really seen as one of, if not the most difficult reasoning tasks that really represent advanced intelligence.
Right.
That critics that would claim, stochastic parrots, really would not expect these models to be able to solve these types of problems. They're not problems that you just copy something from the internet.
And to your point there, famously, especially early on, the large language models, even the foundational large language models, really struggled with basic math, right? Because that wasn't really even remotely their core competency.
Right. So a little bit about how it works. There's AlphaProof is basically a two-stage model, and there's a sort of a generation phase and a verification phase. And they've basically structured mathematical proofs as a sort of a game, like taking steps in an environment. And so, as you know, AlphaGo and AlphaStar and all of these are reinforcement learning based algorithms.
Right.
And so they were able to leverage their AlphaZero RL algorithm in much the same way they would do for chess to take moves in the space of the mathematical proof. I think it's very fascinating.
Oh, that's brilliant.
Yeah, and the key sort of innovation that allowed them to make this happen is structuring the math problem, basically developing that space where you can represent the math problem and take actions. There's a formal language called Lean that's used to represent, it's a functional language that's used to represent math in a way that's completely formal. And so that the model is taking actions in that space.
Okay.
And so that's AlphaProof, which solves, algebra and number theory problems. And alpha geometry is similar in some ways, but they have had to represent a whole different space for that. But basically they have a combination of a neural component that's suggesting moves and a symbolic engine that's doing the actual verification, the mathematics behind the moves. And that combination lets you quickly search the space to find good moves and then take steps from there. Much the way in a chess problem, there's a million possibilities, but there's only a small number that really makes sense.
Yeah, a huge number of possible next states, but a small fraction of them that you would even really want to explore. I mean, this is very related to, protein folding, right? With AlphaFold. I mean, it's very similar.
Yeah, absolutely.
What I love about this is we're touching up upon sort of, computational complexity classes and P versus NP. And it's pretty clear that they're doing things like the generative part is much more difficult than the verification part, right? So you can kind of cheat and use that non-deterministic polynomial time aspect to verify whether these proofs are accurate or not. I personally think that we are right on the cusp. And when I say that, I think, 5 to 10 years before we are going to see things like, the Riemann hypothesis proved using AI systems and things like that. And we're going to have custom drug development with protein fold and all those types of amazing things. I just read, I think it was yesterday, that the ancient Assyrian story, I believe it's considered to be the oldest surviving sort of notable work of literature, that they're now using AI to understand these cuneiform fragments. They have about 500,000 spread out in museums around the world. And there are, as you might imagine, not that many people who read that ancient language. And they have added, in the last couple of years, they've added something like 20 years worth of understanding to this Gilgamesh poem or epic work that would constitute, like decades of manual labor using AI. So, I mean, it's just being leveraged everywhere. I love it.
Yeah, this reminds me, there's in Crete in Greece, there's like the oldest temple in all of Greece. I think it's in Knossos is the name of the temple area. But I remember them talking about how there's this linear A and linear B script. Linear B, they've been able to decipher it, but linear A, which is, I think, thousands of years before BC, like is this really old script. They just haven't been able to decipher it. I would love to see someone go in and just uncover a bunch of history.
I totally agree.
Yeah, wow.
Well, Michael, you want to wrap us up today? You got anything else you want to cover?
Just a short little topic I thought was interesting. So there's a paper in Nature, which we all know is a really reputable journal, that was about recursive model collapse, where...
yes, I read this.
Yeah, so you have a model, and then you presumably could just generate synthetic data, retrain said model, and watch what your performance metrics do over time. And one of the things they showed is that with each successive generation of retraining, model performance degrades and degrades and degrades until it's just, not performant, or it collapses is the word they use.
Yeah.
What do y'all think about it?
Nathan, what do you think?
This kind of calls back to what we were talking about earlier about the text on the internet being more and more AI generated. But I've also heard that so I think I saw this paper, and I saw a statement about how researchers are finding ways to combat that problem more and more. I don't know a ton of details on it, but
yeah,
I don't know. I got the sense that it wasn't something that we were too worried about going forward.
Yeah, I share that sentiment. I think it's the corner case. I mean, it's like if you're compressing an image over and over and over and over again, right? I think that's probably a pretty fair analogy. I would counter that with the fact that almost all of the really interesting large language models that are being developed and have been released recently, everything from Phi 3 to Llama 3.1 relied heavily on synthetic tokens. So I think if you just take a model and get into some type of recursive infinite loop of feeding its inputs just or the as training data as its output, yeah, you're probably going to get some type of collapse. But I also would argue that's not a surprise and not that interesting, and you shouldn't do that.
Yeah, yeah. The fact that it was in Nature, I was like, oh wow, this is reputable. But,
exactly. Yeah. All right. Well, anything else you guys want to cover? I mean, I've got 20 more things, but I think we better wrap it up.
I think so.
All right. Thank you both so much. I appreciate it.
Thank you, Ron.
Thank you for listening to Hidden Layers. This series is hosted by KUNGFU.AI, a management consulting and engineering firm focused exclusively on artificial intelligence. If you have any questions or thoughts about today's episode, or if you know someone we should feature, please visit us at KUNGFU.AI.